I'm Gavin Clark with the National Museum of Computing and Radio Museum, and we're interviewing former employees and customers of Digital Equipment Corporation as part of the 60th anniversary of DEC opening its first office in the UK. It's July the 2nd, 2024, and we are online. I'm here today talking to Mike Burrows. Mike, let's start with the basics, please. Tell me your full name, your place, and your year of birth.
My name is Michael Burrows. I was born in Palmer's Green in Enfield in London, and that was in 1963.
And what was growing up like, and what was your family like?
So let's see, it was, I suppose, fairly normal. My father was an electrical engineer, and he worked for various of the electricity boards, including the London Electricity Board and the Eastern Electricity Board at various times. My mother was a secretary at various times, but when she had children, she stayed at home most of the time. I had a brother, and that was the family. We were not especially well off, but we did okay. There was always a roof over our head and food on the table, so nothing to complain about. I, I suppose I was, and still am, quite introverted, and so I didn't go out and play quite as much as my brother did. He used to call me the hermit as a result. But perhaps as a result of staying at home and reading things, I did well at school, and that stood me in good stead for later life.
So what was school like? What kind of subjects were you into?
Um, well, mathematics and physics. So by the time I got to A level, I did three subjects. They were physics, mathematics, and further mathematics. I remember that when I was, I think, around 14, I did my very best to give up all subjects that involved writing essays. In order to achieve that, I looked at the timetable and realized that if I took French, German, Latin, and technical drawing, it would be impossible for me to do history and geography. And so that's what I did.
And were you sort of what interest did you have? Were you kind of a maker, or were you kind of obviously were you reading books, or what kind of interest did you have?
Uh, I I was interested in electronics. However, I discovered that I was not, I would say, a natural maker of things like electronics because I would get scared about physically breaking things, and also about injuring myself with a soldering iron and things like that. And so I tended to gravitate towards things like calculators and slide rules and eventually computers, because it's really hard to break anything seriously with those. And that made me feel more secure, I suppose, as a child.
So what happened at school? So secondary school comes around, and what's the progress academically? Where do you go? How's it happen?
So I went to the Latimer School, Edmonton, which was very lucky for me, I would say, because it's a good school. Um, they, uh, that's a grammar school, one of the few remaining grammar schools, and I did well there. As I said, I tended towards the sciences and not towards things like history and geography. Um, and I would say I did well. Uh, One of the things that was interesting was towards the end of my time there, I was deciding what to do next. And of course, I wanted to go to university. But my parents had not been to university. No one in my family, even my extended family, had been to university, as far as I know. And so I didn't get much advice, and I didn't know what to do. I thought about applying to Cambridge, and my deputy headmaster wanted me to. But I wanted to do electronic engineering, and Cambridge did not offer a course in electronic engineering. They offered a course in engineering, and electronic engineering was an option in your final year or something like that. And I thought that that was not what I wanted to do. So instead, I applied to University College London, and I got into the electrical engineering department there. And that, I suppose, worked well for me as well. I discovered, to a certain extent, I'd made a mistake in that when I got there, I realized it was not really a department for electronic engineering. It was a department for microwaves and lasers. So, for example, my final year project at UCL involved using a Michelson interferometer to bounce a laser beam off a semiconductor device, and then to look at the changes in the phase of the reflected beam to see if it was possible to use phase displacement to image the depletion region of a PN junction on a transistor. And it turns out it is. But that is not the kind of thing that I expected to be learning when I decided to do electronics. But in the meantime, while I was there, I discovered that I could take courses in the computer science department. So I took a few courses there, and I discovered that they were really easy compared to the electronics courses. And so I spent a fair amount of time doing things in the computer science department. A few courses, but much of my time was spent there just playing around with the computers, and also taking holiday jobs, doing system administration and things like that in the computer science department. And that was my first exposure to things having to do with DEC computers, because that department had PDP-11s, and so I learned a lot from using PDP-11s.
What were describe the computing setup? How were you using the PDP-11s?
So I remember vividly the very first programming exercise we were made to do in the first course I took in the computer science department. We used a PDP-1110 to compute primes, the first primes from 0 to 100 or something like that, using the Sievert Eratosthenes using the front panel switches to program the PDP-11. So you had to program it in machine code. You couldn't even use an assembler. And that was entertaining. And then after that,
how complicated is that? Sorry, Dave, how complicated is it? How is that complicated to do? That's is that taking you several steps back before you can actually get on with solving the problem?
Well, it's slow, I would say, because you have to work out by reading the manual exactly what bits to set in the instructions, and then for each instruction you have to set it up on the front panel switches and deposit it into memory by setting an address and the data and pressing a button to write that to memory. So it's not something you want to use to input a large program, shall we say, especially since there's a queue of other students waiting to use the machine, because there was only one for a whole class of us. But it's not too bad as long as the program is small and you understand the machine well. It is not a pleasant environment for debugging, so it's very important to check and recheck and get everything right before you do it. And then, of course, the reason that they gave us this was just to give us the experience of having done it. And that was true of the next set of exercises too. The next thing they had us do for a few weeks was various programming tasks, again on the PDP-1110, using PDP-11 assembly language, but this time programmed on punched cards which you would dump into a hopper on top of the machine, press a button, and the assembler would run, and then the program would run. And of course, that meant that you could retry and write bigger programs. Again, this was just to give us the experience of knowing what that was like. And after several weeks of that, then they let us log into PDP-11s running Unix, which was so much nicer. And this was my first experience touching Unix systems.
Well, so you're getting an early taste of DEC there, and you started. You said you were kind of unaware what was happening around you. You encountered your thesis advisor, David Wheeler, didn't you? I think at some point here.
Well, what happened? He was at Cambridge. I was still at UCL at this point, and what happened was, I think, sometime around my second to third year. Or must have been my third year. My head of department, a guy called Eric Ash, this is back in the electrical engineering department, he came to me and said, "Have you considered doing a PhD?" And I said, "No." And he said, "Well, you should. Let me talk to my friend Roger." And Roger turned out to be Roger Needham, who was the head of department in the computer lab in Cambridge. And so I found myself interviewing for a graduate student position in Cambridge, and I first met David Wheeler at that point. And I had no idea who he was. I didn't know that he was actually quite famous. And that was probably good because it meant I wasn't as nervous as I might have been. They offered me the chance of going to Cambridge.
How important was David Wheeler?
He was the first PhD in computing. All people before him who had worked on computing had got PhDs in physics or mathematics or things like that. He was the first student who actually did a PhD in computing. He worked initially on the software side of the EDSAC. The EDSAC was, you could say, the first machine that was that stored the program in its own RAM. They didn't call it RAM at the time, but we would call it RAM now, and therefore didn't read the program as it was running off punch cards or paper tape. It used RAM, and that means it could do branches and loops and things like that. And it was the first machine that had those features where the machine was big enough and useful enough that you could write really interesting programs. Another machine with some of those properties had been built at Manchester before, but that machine, although it was groundbreaking and a great achievement, its RAM, which was built out of Williams tubes, was very small. It was something like 32 words or something like that. And as a result, you could write tiny little programs, like you could write a program to test whether some integer was prime or not, but you couldn't really write a large program because there just wasn't space. Mm-hmm. And as a consequence of this, on the EDSAC, where there were many kilobytes of RAM, it was necessary to invent much of what we take for granted now in modern programming, things like procedure calls. David Wheeler had to invent those and he had to invent the way of actually achieving it on the EDSAC hardware. The EDSAC hardware had not been designed with a procedure call instruction. And so David Wheeler faked it with jumps and self-modifying code. And for a while, the procedure call was known as the Wheeler jump because that was what he did. And of course, nowadays, if you tell someone who programs that someone invented procedure call, they can be quite surprised because it's so fundamental to everything we do that people sometimes forget that someone had to invent how to do that. Mm-hmm. David Wheeler went on to, he stayed at the Cambridge Computer Lab most of his career. He went on to design pieces of hardware, design complicated algorithms and software, and of course, one of the things he did was invent the core part of a compression algorithm, which I forced him to publish by writing the paper and putting our names on it, because otherwise he wouldn't have bothered. But that algorithm, turns out, is still very important in the world of bioinformatics, because it allows you, as some people later discovered, it allows you to build an index for a piece of text and compress it at the same time. And so that means that you can compress a DNA sequence and still, in the compressed form, be able to do searches within it, which is very useful in bioinformatics.
So you heard David. So you make it to Cambridge and you're doing a PhD. Is that correct? And David Wheeler is your thesis advisor. Is that correct?
Yes, that's right.
So you've come a long way. You've come a long way. I mean, from this kind of like I suppose a certain uncertain academic background, and you're now at Cambridge. It's quite an achievement already, isn't it?
Yes, and I feel I was very lucky. I received two excellent pieces of advice. First of all, from Eric Ash, who I mentioned, and also when I was getting to the end of my degree at UCL, I decided to interview for a normal job just to see what the interview would be like. And I interviewed at British Telecom Research. And I went through the interview, and at the end was talking to the last chap on the interview schedule. And he said, so what other places are you considering? And I told him the other place I was considering was doing a PhD at Cambridge. And he said, nowhere else? And I said, no, nowhere else. And he said, so it's just between us and the PhD at Cambridge? And I said, yes. And he said, well, let me tell you, we're going to make you an offer, but you should do the PhD. And that advice, I think, was excellent. And so between him and Eric Ash, and then, of course, Roger Needham and David Wheeler accepting me, that was a very lucky break, which put me on a certain trajectory. Another thing that was very fortunate was that David Wheeler was not too fussy about what I did for my PhD. And so I ended up doing things to do with distributed file systems. And he was not particularly interested in distributed file systems. So every week I would meet with him, and we would talk about the things that he was doing, and we would barely touch upon the things that I was doing, but he was perfectly fine with that. I spent most of my time talking to Roger Needham, actually, because his intellectual interests were more aligned with the things that I was working on. Another thing that was fortunate is that Roger Needham viewed PhDs as apprenticeships. And so if people had eclectic tastes and they wanted to work a little bit on this and a little bit on that, that was fine with him as long as they were still learning things. And that suited me down to the ground. And I spent much of my time doing all kinds of things at Cambridge that were not directly related to the subject of my dissertation. And then another thing that was incredibly lucky was just as Eric Ash had come to me and asked me if I considered doing a PhD while I was an undergraduate, at Cambridge, Roger Needham came to my desk one day and asked, have you ever considered doing a summer internship? And I said, no. And he said, well, you should. Let me talk to my friend Mike Schroeder. And Mike Schroeder turned out to be a person who had worked at Xerox PARC and at that time worked at DEC Systems Research Center. And so the next thing I knew, I was flying out for an internship, that was in 1987, to Palo Alto in California, to the DEC Systems Research Center. And that was an incredibly lucky break for me, because it turned out, given my interests, that particular establishment was probably the best place in the world at that time. It contained
what was happening? So if you could describe that. So what is the facility like? What is, most people won't have even heard of it. So what is the research center at Palo Alto like? Is it a campus? Is it one building? Is it large? Is it small? And what happens there or happens there?
Well, it no longer exists, but it was one building. It looks like a red brick building on the corner of Alma and Lytton in Palo Alto. That building is now occupied by Amazon. I say it looks like a red brick building because the things that look like red bricks on the outside are actually a facade. It would be illegal just to build a brick building in an earthquake region. So it really has a structure with steel beams and reinforced concrete. So, in fact, it wasn't the only DEC research lab in Palo Alto. There was also, for example, the DEC Western Research Laboratory, DEC Whirl, and that was just a few blocks away. And later there was another one, DEC NSL, the Network Systems Laboratory, also a couple of blocks away. So it was in a competitive field, even within DEC.
What kind of work? What kind of research were they doing there compared to the other DEC facilities?
Well, we were all doing things to do with computer systems, mostly. A lot of networking, building new types of computer, building new operating systems, trying things out, new algorithms. So some of the things that were done at the Systems Research Center, so Chuck Thacker was there. He was the head hardware person. He had been at Xerox PARC and was responsible for, at Xerox, for the Alto, which was the first personal computer. At DEC Circ, he built the Firefly, which was I think it was the first multiprocessor workstation. So it was unusual in the 80s to come across a multiprocessor. But as an intern, I had a multiprocessor on my desk, and that was the first time I'd used a multiprocessor. Chuck also built a couple of networks. There was a network called Autonet, which later became known as AN1 because the trademark Autonet was owned by one of DEC's customers, and a follow-on network called AN2. And I worked with him on both of those networks. I did some of the software necessary for those networks. And Chuck also worked on a thing called the Alpha Development Unit, which was the first system that used DEC's Alpha processor. It was never released as a product. It was designed specifically to allow DEC's software product teams to develop software for the Alpha before the other Alpha systems were ready. And the reason that was done in a research lab is that research labs are used to building 100 of something because they typically have only dozens of people. Whereas product teams are used to building thousands or millions of something. And so it's a different style of hardware development. As a result, the ADU was, a product engineer might say it was over-engineered because it could be. The whole goal of the thing was to get something out fast and run the chip at full speed and work. And we didn't actually care about the price, and we didn't care about whether it was noisy. This thing sounded like a hovercraft. So that was the sort of thing that was done on the hardware side. On the software side, there was an operating system called Taos, which was designed for the Firefly workstation. You would call it a microkernel-based operating system. in today's terminology. So there was one address space that contained just device drivers and I think the virtual memory system, but most of the operating system was in another address space. So all of the file system was done in a separate address space, which was not the kernel.
Mhm.
That was all programmed in. Sorry, that was all programmed in modular.
So I was going to say,
Sorry.
so what's it like there? I mean, you come there, you must be, so what, you're in your early 20s and you're in the States. This is your first trip to California. How are you kind of feeling about this at this point? What kind of experience is it for you?
Uh, as you say, it was my first trip to California. It was actually probably only my second trip outside of the UK. And I was quite apprehensive, was quite young. I was not the youngest intern at the time during my internship. There was at least one who was younger than me, but I was quite young. I couldn't yet drive, which is tricky in California.
How did you get around? I was going to say.
I got rides from people. There was one time when the interns all decided that they would visit Napa, which is a wine growing region to the north of San Francisco. And I think I was a great disappointment to them because I don't drink wine. And yet I could not be their designated driver because I couldn't drive. And I found the trip to the wine country quite boring because wineries are not that interesting if you don't drink wine. One thing I found at DEC was, again, it was useful not to be fully aware of who everybody was, because the organization had a fair number of famous people. I've mentioned Chuck Thacker. It also had Butler Lamson, who's one of the greatest computer scientists there has been. A Leslie Lamport, who's responsible for a fair number of groundbreaking algorithmic developments. And a number of other people. There was a fellow Brit also who'd gone through Cambridge called Andrew Birrell. He's, I suppose, most famous for being a co-author of the paper which described remote procedure calls for the first time. That was Bruce Nelson and Andrew Birrell, that paper. And so on. It was just full of famous and very smart and good people.
Were you aware of this kind of? Were you aware of these names at the time, or were they just people?
I suppose I was aware of some of the names, but I didn't realize exactly what they had done, and that meant that I was less frightened of people. So I'd noticed that the other interns wouldn't dare to speak up. This was driven home to me on a visit that we did to one of the other labs. All the labs in the area, and there were quite a few. There was us, there was the DEC World Lab, there was Xerox PARC, there was Sun Labs, HP Labs, and so on. They would, during the summer, they would get together, and the interns from each lab would visit each of the other labs just to get a feel of what the other labs were like. And I remember when we visited Sun, they wheeled out Gosling, who did Java and Use, and I had noticed that in all the previous talks that they'd given us at Sun to this point, I was the only person who said anything among the interns. None of the interns had asked questions except me. And when they wheeled out Gosling said to the person who was running the event, "So is it going well?" And the person pointed at me and said, "Well, we've got a live one here." And again, I wasn't put off by having someone as famous as James Gosling in the room, because I didn't know that much about what he had done, and so I think that actually helped me. But on the other hand, it's also good to know what people have done, just so you know who to talk to when you need to know something. So what else can I tell you?
So you were there. You described this as perhaps your most productive summer ever. Why was that? What did you do that made this your most productive summer?
Well, so my project, which my host Mike Schroeder had arranged for me, was to speed up the RPC system for the Firefly. And I arrived and I thought that that was a little boring as a project. What it involved was finding the path through the code that would be taken in the ideal case, the so-called fast path for sending an RPC and receiving it, counting up all the cycles and working out where the time went, and then working out exactly which instructions were superfluous and how to optimize it. And so I did that, and I managed to get a factor of 2 improvement out of the performance. And given the speed of the processors that we were using, it was about as good as one could do at that point. But I had not thought that this was terribly exciting, but it turned out to be interesting enough after Mike Schroeder wrote it up that he created a paper and got it into the best conference for that type of work, and it was considered one of the best papers in the conference. Secondly, Mike Schroeder made a serious blunder during the summer. He went on vacation for 2 weeks. He went to the Arctic with his family. And I was left on my own, except that my head of department from Cambridge, Roger Needham, was also visiting because he was on sabbatical and chose to come to the same place. And so what happened there was I had been working on authentication protocols, amongst other things, back in Cambridge, and I chose to give a talk about that at DEC. And I described a particular way of doing things, and at the end of the talk, Butler Lamson said, "How do you know it works?" By which he meant, have you actually proved that this thing works as advertised, as opposed to just assuming that it works? Because sometimes building it and trying it is not enough, because there might be issues, and this is particularly true of security, which is very tricky. And so I sat and wondered about that, and then I went to Roger, because I knew that he and Mike Schroeder a few years before had written a paper with an authentication protocol which was widely acclaimed, and it turned out that a couple of years later people discovered it did not work. And so I knew that this topic was dear to his heart too. So we sat down and thought about it for a while, and we tried to come up with a formalism to describe authentication protocols so that you could reason about them and discover certain types of error. It certainly couldn't discover all types of error. It didn't, for example, worry about secrecy. So it wouldn't actually tell you if you had sent your encryption keys in the clear. But on the other hand, if you had an error having to do with timing, or an error having to do with which parties in the authentication protocol you trust and what you trust them for, that kind of thing, it could highlight that and bring it out. And that was interesting to Roger, because that was exactly the type of error that there had been in his protocol before. So neither Roger nor I were logicians. So we created a formalism, but we were not sure that it was right, because this is another thing that it's easy to get wrong. So I went around canvassing some of the theoreticians at CERC, and I was pointed at Martin Abadi, and he is a logician, and he looked at our formalism and tut-tutted and corrected us and fixed it up. And the three of us created a paper which also got published at the same conference that the first paper about the RPC performance got published, and was also acclaimed as one of the best papers in the conference. And so that one summer led to two extremely good papers, which were well regarded. And on top of that, I managed to have interesting conversations with a number of other people at DEC about their projects, on subjects ranging from garbage collection to distributed file systems, and they went well. As a result of that, I really liked the place, and they seemed to really like me, and they had me interview for a full-time position at the end of the internship. And it was very interesting. Mike Schroeder said, well, you know everyone, why don't you wander around the building and find people who are willing to interview you and try to pick people that you haven't had conversations with before. So I did that. Interviews at CERC would normally take 2 days. You give a talk at the beginning of the interview, and then you spend an hour with each of perhaps a dozen people, and then you have lunch with some people and dinner with some people. I spoke so much during the interviews that I lost my voice halfway through. And so the interview had to be stretched out over more like a week so that I could get my voice back and I wouldn't lose it again. And apparently I didn't upset anyone with what I said, because they made me an offer. I have never been good at job offer negotiations. And so when I saw the offer, I said, can you live on this? And they said, yes. And I said, then I'll take it.
And what was the job? What was the position?
Interviewing.
What was the position they offered you?
It was a researcher. One of the things that was very nice about DEC was that, to a large extent, you didn't care very much about people's exact title, how much they'd been promoted. You were largely unaware of it. There was a distinction between the research staff and the non-research staff. And of course, some roles, it was very obvious what the people did. It's like administrators did administration, and the lab technicians sat in the lab and did things with the circuit boards. But among the researchers and the technical staff in general, you tended not to care or know exactly what people's job titles were or their level in the organization. Instead, you worried a lot more about what they seemed to know and what they seemed to be expert in. And that seemed to me very good. I have not found as pleasant a working situation anywhere else that I've been since.
We hear a lot about the DEC engineering culture. How would you, I suppose, sum that up in terms of what you experienced there during this period?
Well, of course, my experiences may be somewhat different from people in other parts of DEC, because research was different from one thing, and the Systems Research Center was somewhat different even from other parts of research. Part of that difference was that we were on the West Coast, and DEC, of course, was based in Massachusetts, on the East Coast of the United States, and as a consequence, we could get away with things that they couldn't get away with on the East Coast.
Such as what kind of things?
The main one was we had offices. Most people on the East Coast were in cubicles, but we had offices. That was not true when I was an intern. As an intern, I was definitely in a cubicle. But after that, when I joined full-time, I was in an office. Of course, some people had better offices than others. Some people liked to be on the higher floors, so they got a good view, or they liked to be in a corner office, so they got a view in more than one direction. I was, I suppose, the second youngest person in the building when I joined. And so I was put in an office on the second floor, which was the lowest floor that any of the researchers sat on, with a window just looking out onto the car park, which was not considered a very nice office, but then I don't like looking out of the window anyway. I just closed the blinds and never opened them the entire time I was there, 13 years. So I was perfectly happy, and being in an office was just great because it meant that most of the time, if you wanted to have a meeting, you just have the meeting in your office. It had to be a big meeting before you needed a meeting room. So the building had very, very few meeting rooms, but they were always free because almost all meetings took place in people's offices.
And did you get to
and you
get to
could
see
have-
did you get to see your other did you get to Maynard? Did you make it back to any other offices in the US or even to Reading in the UK?
I never visited Reading. I did not visit Maynard. I did visit a number of DEC facilities in Massachusetts. The main one I remember visiting was in Shrewsbury. There was I mentioned earlier, I think, that I worked on some software for a local area network that turned into a product for DEC. The product, if you wanted to look it up, it's called GigaSwitch ATM, and the associated network adapters. And there was in 1995, there was a video on demand team in DEC that was created in Shrewsbury, Massachusetts. And this was just at the time when, if you did a back of the envelope calculation about the costs and performance of the various things, you could come to the conclusion that doing video on demand to people's houses was now economically feasible and you could make money at it. And so lots of people were trying to do it. You wouldn't make much money because it was only just economically feasible. It became much easier later, of course. But anyway, they were trying to build servers using our network to transport the video. And they were having trouble with the performance of the networking. And so they flew me out there to help with it. I did not enjoy the trip, but there was one highlight, which was that they needed me in such a hurry that after I got to Boston Airport, they flew me in a helicopter from Boston Airport to Shrewsbury, Massachusetts, which was the first time I'd ever been in a helicopter. And that was great fun.
We heard about the DEC fleet, the helicopter fleet. It's supposed to be one of the largest private helicopter fleet. So this is your first time. What do you remember about the trip?
Well, I just remember being excited and asking the pilot, "Can I sit in the front?" And it was clear that he was amused by my excitement. I remember the second time I went in one of DEC's helicopters. I can't remember which facility I was coming from, but anyway, the weather that day was not great. It was windy, and there were several passengers waiting for the helicopter. And I bounded up to the pilot and I said, "Can I go in the front? Can I go in the front?" And he let me go in the front. And this probably was only my second trip in a helicopter, so I was still excited. And he took off, and it was clear that the thing was shaky because of the wind. And I said, "Wow, this is exciting." And he said, "No, it's not." Because it was clear he was having to pay attention to keep the helicopter on an even keel in the windy conditions. But anyway, I found it still entertaining.
So again, you're doing really well. I mean, you're still you're very young, and you're kind of in the middle of this like amazing experience. What were you aware of? I suppose DEC's reputation, or did it have? Were you aware of what you were kind of in the middle of as a company at this point?
Yes, I suppose. Well, after a year or so at DEC, I became fully aware of how DEC was regarded.
And how was it regarded, would you say, at this point?
Well, I think people thought well of its engineering. People thought well of its ethical principles. That's partly because Ken Olsen, the founder of DEC, and who was still the CEO when I joined, I think he had a religious upbringing of some kind, but in any case, he was very ethical. So, for example, he did not like the idea of people getting drunk at work. And so it was a firing offense to bring alcohol into a DEC facility. And that was unusual, but at least you knew where you stood. It didn't bother me, of course, because not only do I not drink wine, I can't stand any alcohol. It's too bitter for my taste. But you got the impression that DEC was an ethical company. I mean, it might do things you didn't like, but it wouldn't do anything that was unethical.
How was that kind of communicated to you? Was that something you picked up on as a vibe, or was it actually presented to you? How was that transmitted to you?
I just picked it up as a vibe. I would say you got the feeling that doing something that was bad, either for your colleagues or for customers or for the public in general, was just frowned upon at DEC. And other companies aspire to that, but DEC actually achieved it. People, for the most part, wanted to do the right thing at DEC, both for the company.
So I was going to say, sorry to interrupt you. I was going to say, what did do the right thing mean, and did it have an interpretation in terms of your work?
Oh, so I suppose the best example of that I have came up when I started to work on Alta Vista. I suppose it'd be okay if I started talking about Alta Vista at this point.
Well, what is Alta Vista, and why is it important in the history of the internet?
So, Alta Vista was a web search engine. We built it in 1995. It went live on the internet in December 95. And it wasn't the first web search engine, but when it went live, it was 16 times bigger in terms of the number of pages indexed than its nearest rival. And so it quickly became the most popular search engine on the web, and it didn't lose that title for several years until it was overtaken by Google. And I think it was probably overtaken in 2000, 2001, something like that. And I suppose the primary reason that it was eventually overtaken was that running a search engine was not DEC's primary motivation. And so they didn't put as much into it as another company would. For Google, it was Google's bread and butter. They absolutely needed it to work, and they needed to be the first and the best thing that people thought about when they wanted to search. So,
what made
so
it
eventually Alta Vista.
What made it so unique? Is it was the size of what it could search, it was the speed at which it could search, the accuracy at which it could search. What were the things that made it so different to?
So I would say that Alta Vista. So the first thing that people noticed was that the index was so much bigger. It indexed many pages that other things just couldn't find at all because they hadn't bothered to index them. The software was faster at the time than anything else. One of the ways that you can see that is that in web search, the speed or the amount of resources, computational resources that you have to put into a search is linear in the size of the index in general. And as a consequence of that, if you have an index that's 16 times bigger, you have to put 16 times more effort into searching it. And we could do that for two reasons. First of all, I was very careful in writing the software to make it as efficient as I could. And also, DEC had some very powerful machines at the time. The reason, in fact, that Alta Vista got built was that it was not because we wanted to create a web search engine. What we really wanted to create was an example of how fast DEC's machines were. So it was basically a way of showing off, boasting about how good our hardware was. The project was first proposed by a person in the network systems lab, one of our sister labs in Palo Alto, called Paul Flaherty, and he suggested that we build a web index and use the Alpha Server 8400 as the machine to serve the index, because that was the biggest machine that DEC made at the time. And it was a particularly potent machine.
How big was it compared? Because it was
But
one of the biggest at the time, the Alpha systems were they were groundbreaking for the time, weren't they?
yes, so the machine physically, the size of a large commercial refrigerator, and initially, I think it had, let's see, 8 slots, and each slot could take either a 2 gigabyte RAM card or a 2 CPU card, and you could mix and match RAM cards and CPU cards in among those 8 slots. I think we chose to use 4 slots for RAM and 4 slots for CPUs initially. So when we first launched, we did it on as cheaply as we could because we hadn't proved ourselves. And so I think we had the minimum. We had 1 RAM card and 1 CPU card. So we started out with 2 CPUs and 2 gigabytes of RAM. But very quickly, we grew out of that. And after that, we had 8 CPUs and 8 gigabytes of RAM. And as the years ticked by, we got faster CPUs and more RAM on each card because with the progress of technology, of course, we could squeeze more RAM onto the cards.
So this is DEC's biggest machine of the day, and the Alpha server it's 64-bit, isn't it, rather than 32-bit, I think, isn't it?
Yes, that's right.
So what was you've got this, so the suggestion is we want to show how good our servers are, aren't we? Paul comes up with this idea of we're going to showcase our servers.
Yes. So what he did was his plan was to use an Oracle database to do the indexing, which alas was not a good idea because relational databases do not make good text indexes. But that was his initial plan. He needed a web crawler that could read the pages from the web. And so he convinced Louis Monnier, who worked at DEC's Western Research Lab, to write that web crawler, which was called Scooter. Paul, because he wanted to convey the notion that this was being done in Palo Alto, he called the project Alto Vista, ALTO Vista. Now, Louis Monnier, who is French, and thus is more keenly aware of gender agreement in languages than Paul was apparently, couldn't abide by the fact that Alto is masculine and Vista is feminine, and so he gender corrected it to Alta Vista, and that's where the name came from. At some point, Paul's negotiations with Oracle to use an Oracle database for this fell through, and Louis was left having written a web crawler, but not having any plan for putting an indexing system behind it to actually build the index. In the meantime, I had been working on an indexing library because of some involvement in an earlier project on computational lexicography with the Oxford University Press. The indexing library, I worked on it sort of part-time while I was working on the networking software. And it had got to the point where it was operational, and I felt that it was pretty close to done. But what I really needed to try it out was a large amount of text to index so I could see whether it would behave well under heavy load, and to thrash out any bugs that there might be remaining in it. So I went to Louis and I said, when when you've got a copy of all these web pages that you're going to crawl, could you keep it so I can test my indexing library on it? And he seized upon this opportunity and said, well, why don't we work together? He said, I'll do the web crawling and you build the indexing and the query library, and we'll complete this project, Alta Vista. And foolishly, I said yes. I say foolishly because it turned out to be an enormous amount of work. One of the things that Louis wanted to do was get the thing ready before Christmas 1995, because he wanted, for some reason, to say to the world, this is our Christmas present to the internet. That was his phrase. And it turned out that getting it done in the time, only a few months remained before Christmas, was an enormous amount of work.
How much work was it? What kind of scale? I mean, what are you talking about in terms of long days, working nights? I mean, what was the depth of the work you had to go to?
Long days, working nights, cancelling trips. I had to cancel trips to conferences. I had to work weekends and evenings. And the other thing that was even more striking was that I knew that as soon as we released this, as soon as we went live and clients were connecting to us from the internet, that the workload would go up.
Why was that?
Well, because as soon as you make something live, you suddenly have to look after the artifact that you have built, which is being hammered on by people, some of whom are malicious, and they will uncover bugs. The load will get so high that the thing doesn't behave properly, because computer systems, if you load them beyond the normal operating regime, they tend to behave less well. They fail in interesting ways that you would not have foreseen. Sometimes their performance drops if the load increases past a certain level, which makes everything worse. And people will be reporting bugs all the time. And so simultaneously, you have to monitor the system that's running, and you have to be fixing the bugs and hoping that you haven't introduced new problems when you fix the old ones, and pushing those things out. And of course, people would also want the index to be kept up to date. So there would have to be a continuous stream of updates going through this thing. So there would be many more things to take care of once the thing had gone live. And so the workload would just go up.
Did you say the work made you physically unwell? You got sick through working on the project?
I did. This happened in early 1996. I worked so hard that I assume that I caused my immune system to work less well than it did, and I contracted an autoimmune disease called CIDP, chronic inflammatory demyelinating polyneuropathy, which you can look up. You can see why they abbreviate it. It basically means my immune system is eating away at the myelin sheaths of my peripheral nerves. So you can think of it as a very distant cousin of multiple sclerosis. In multiple sclerosis, the immune system eats away at the myelin of the nerves inside the brain and the spinal column. That's inside the blood-brain barrier. But in CIDP, it's the opposite. It eats away at the myelin only outside the blood-brain barrier. As a result, CIDP is less serious than multiple sclerosis because it's easier to get drugs to the affected area, and because it doesn't affect your brain directly, it doesn't stop you thinking, and it can't affect it can't affect your vision or your hearing, things like that. What it does instead is first it causes you to go numb and weak from the periphery, starting at the fingertips and the toes and moving up. If left untreated, it can kill you, because eventually it can take out the nerves that control your lungs, and so unless you're put on a ventilator, you might die. But that probably takes months. there are acute forms of it. There's a thing called Guillain-Barré syndrome, which is basically considered to be the acute form of CIDP, which is considered the chronic form. And Guillain-Barré syndrome can be very frightening because it can essentially overnight cause you to be bedridden. And if you don't get to a hospital very quickly, you might die. But with CIDP, you have weeks to react.
So what happened in your case? Did you, so because it launched Autovist launched in November 1995, so 96 you're diagnosed with this condition. Did you have treatment for that as a result of this, what happened to you?
Yes. So I had noticed that I was starting to go numb, and I went to see a doctor, and the doctor did all kinds of blood tests, but he couldn't figure it out. It was interesting to behold, though. At one point, he looked at my gums and he looked at my fingernails, and he said, "Well, you don't have lead poisoning. No one's trying to kill you with arsenic." And I said, "Have you treated someone who was being poisoned systematically with arsenic?" And he said, "Oh, yes." But he couldn't figure it out, so he sent me to a neurologist. But that neurologist, one of the first things they do in a case like this is they do a nerve conduction study, which involves giving you little electric shocks, let's say up the arm, perhaps here, and measuring how long it takes between the electric shock to a muscle twitching in your hand, say. And then they get out the tape measure and they compute the time and the distance and then get the nerve conduction velocity. And in a disease like CIDP, the nerve conduction velocity is often significantly reduced, so it's one of the main indicators. Unfortunately, his machine for giving the electric shocks was broken. It had an intermittent open circuit, and so all it did was make me really upset because I could never tell whether I was going to get an electric shock, and he kept turning the voltage up in order to make the thing work. But eventually, I abandoned him and I went to the neurology department at Stanford, which is close by. And the first question I asked was, could it be CIDP? I asked this because one of my colleagues had told me that he thought that it might be this. It turns out that was a colleague who actually had multiple sclerosis, and so he studied the literature. And the people at Stanford said, yes, it could be CIDP, but we have to do a few tests first. And my heart sank because I'd been doing tests for 10 weeks with the previous neurologist at that point, and I had got progressively weaker and got to the point where I was having difficulty with stairs, having difficulty even getting up a curb when I was crossing the road. But unlike the previous guy who seemed to be taking his time, the people at Stanford, they took only 10 days to do a whole battery of tests. And they gave me great confidence because I could see the algorithm they were following. I found the differential diagnosis chart that they were following, and I could see exactly which test they were going to do next, and I could see if it went this way, they would do this test, and if it went that way, they would do that test. And at one point, I could see, yes, today you're going to give me, you're going to take some spinal fluid, aren't you? And the chap said, yes, lie down here. And so it was very nice to be able to predict what was going on. And then it got to a point on the chart where I could tell, because of the diseases that remained in my part of the tree, either I had CIDP or I was going to die very soon, because CIDP was the only remaining disease there that was actually treatable. And fortunately, it turned out to be CIDP. And so after 10 days of testing, they said, well, we haven't had results from the last couple of tests, but we think it's CIDP. You get intravenous immunogammaglobulin today. And so this is a blood product. You sit there for a couple of hours and they infuse it into you. It's basically other people's antibodies. And my very vague understanding of how it works is that it puts so many antibodies into your bloodstream that it effectively interrupts the feedback loop in your own immune system, because it confuses your immune system and it fails to remember to make the antibodies that are causing the trouble. It's only a temporary solution because once your body has cleared those antibodies out, which can take a few weeks, your immune system starts making the bad antibodies again. But as long as you keep getting this stuff, it works, and the sensation comes back because your nerves recover. It has the annoying side effect that it gives you flu-like symptoms. So initially it makes you feel worse. They didn't tell me about these side effects at first, and so I was terribly depressed for a couple of days because I just felt worse. And then one day I woke up, and it was quite biblical. On the third day I arose, and the pain and weakness had gone. And I still have to take that medication. Now I take it subcutaneously, but it works, and most people can't even tell that there's anything wrong with me. Well, at least not that.
That is quite. I wasn't expecting something like that, but that is quite an incredible story. So, did you? That is an amazing medical story. You weren't aware of this at the time, so you're still working on the project back in the back end of 1995, and this work is making you ill. How is the project going at this time? You were still managing to get through it in spite of the health?
Well, I felt incredibly stressed. There were, especially when I started to feel ill, I am told that my colleagues were told by our manager to give me some room because it was so obvious that I was stressed and irritable. But I did manage to get done the things that needed to be done. As I predicted, as soon as Alta Vista went live on the internet, the workload went up. One of the first things that happened was that we discovered that our choice for a web server was a poor one, because even though it worked, it was not a high-performance web server. And so I decided that I just had to write a new one. And so I did during a couple of weeks in December of 95. It had only taken a few days for us to notice how poor the performance was when the load started to go up. And I managed to produce something that I can't remember exactly how fast it was in comparison, but it was probably 30 to 100 times faster than the one we had been using. And it was not because I had any special tricks. It was just because the web server we had been using was just so abominably awful. And that allowed us to serve for a few months. But the load just kept increasing. As word of mouth spread on the internet, more and more people started using us as their web search solution. And I think the load would go up by something like 10% a week, something like that. I can't remember the exact numbers. We had the problem that although we had very fast machines and we worked for a company that made those machines, we were, as the story goes, the shoemaker's children. The shoemaker's children go barefoot because the shoemaker sells the shoes he makes and he can't make money by giving shoes to his own children. And the same was true for us. DEC made money from those machines, which were very expensive, if it sold them. And it did not make money by giving them to us. So it was actually quite hard for us to get machines. Mm. Louis Monnier was the person who was negotiating all of this for our project. I was very happy about this because being an introvert, I like to sit and program, and I don't like to have meetings with lots of people trying to argue for more money or more machines or whatever. And he took care of all of that. So eventually we did get machines, but they were always later than we would have liked. And as a result, every week I had to make the software go faster. And that was a real strain. Because, of course, I had already written the software to go as fast as I knew how at the time. And so I just had to invent new things almost every week. I would think to myself, what can I do now? And I came up with a lot of tricks to make things go faster.
And how much of this...
But it was...
I was going to say you because you're part of your work. You mentioned the indexing that you've done in your student days, how this has kind of formed the basis of the work with in the early days in the software. But you're kind of now building on that as well, aren't you? And you're bringing in ideas from Karen Spark Jones and other people as well to kind of build this out, aren't you?
Yes. So for the basic ranking, I used ideas from a paper by Karen Spark Jones and her husband, Roger Needham, who I mentioned previously. And I just used the formulae that they provided. And I just used my underlying query library to implement what they specified. And then, of course, there are a bunch of heuristics that we added to give special weight to words if they were in the query and they happened to be in the title of the document, that kind of thing. Closer to the front of the document was better. Words close together if they were in the query was better, that kind of thing. But there were many tricks to improve the performance of those things, either for general purpose queries or indeed for malicious queries, which people sometimes sent us. Sometimes people would send us things deliberately to slow us down. And so I would find ways to recognize those things and make them efficient, or make them appear efficient and give a reasonable answer, even if I wasn't doing the whole work.
Did you have any support on this? Because obviously it's all coming down to you, really. Or did you have a team you're working on to improve the software, or is it literally coming down to you?
Uh, so at first, it was essentially me and Louis writing almost all the software. There was a chap called Stephen Stewart who helped us with setting up the networking and the computers in the data center, which the machine room, which was at WRL. Paul Flaherty by this time had disengaged from the project, so he didn't write any of the code. After a few months, it became clear to the company that this was generating a lot of good publicity. And so they started to give us more support. And so we got an engineering manager, we got a person who worked on operations, keeping the machines up. But a lot of the day-to-day running of the thing for a fair number of months, maybe 6 or 7 months, came down to me. And this was primarily a problem because there's only one of me, and the site was up 24 hours a day. So this was another reason for the stress and medical problems. I was working 14-hour days every day. And if anyone is thinking of doing that, I recommend against it. It does not work if you have to do it for more than a few days.
And how big was the workload? I think you said it was you were looking at, was it 70%, 7% increase in traffic a week? Was that what kind of volume by the time what was the maximum you were kind of seeing, I suppose, by the time you moved away from the project, if there is such a date?
I can't remember exactly. We were certainly doing. I can't remember. It was a lot of queries per second. I eventually started to move away from the project in 1997, and I probably wrote the last piece of code for it that I did in 1998. Okay. That was another optimization to make things work better for the next version of the alpha processor that came out. I think I got another factor of 2 out of the code compared with what the code would have done on that new processor, just by tuning it for the processor and programming everything in assembly language in the inner loop.
So tell me this, go back to this conversation started by DEC's culture of do the right thing, and you're about to say, I think Alta Vista was the example of that. How was Alta Vista the story of do the right thing?
So that came up before we'd actually launched on the web. We first built a trial index with 10 million web pages, and we made it available inside the company only. And then we looked to see how our colleagues from the rest of the company used the service, because that would inform what we needed to fix and make better in general before we launched. And so, of course, I looked at the logs to see how the service was behaving, and I could see the queries that people typed. And on that first day, it was obvious that we did not want to be looking at those queries. Because what we noticed was that the first thing people do is they look up their name, and the second thing they do is look up something you don't want to know about. Things like what diseases they have and things like that. Sometimes even less savory things. And so we immediately decided in one day that we had to do something about privacy. So we decided to prevent people from looking at the raw logs. We knew that people in other parts of the company, including ourselves, would want to use the logs. For example, I wanted to use the logs because they would allow me to run tests and to replay things so I could see how well my optimizations were working, and if I changed the ranking algorithm, see how well that was working, things like that. So I wanted to use the logs, but it was too dangerous to see them in their raw form. You had to remove the relationships between queries, so you couldn't tell, yes, that person with that name was the same person who queried that particular query, that kind of thing. So what we decided was that there would be one person in the whole company, and we picked someone who was in the network systems lab, and she would be the responsible person, and she was allowed to look at the raw logs. And if anyone else asked her for logs, she would work out what they needed and sanitize the logs into a form that didn't reveal who people were and didn't allow you to piece together this person had done that query. Or the person at this IP address had done that query. That would all be taken away. And of course, that person who had this access, she was under strict instructions to forget everything she saw. And of course, even that isn't as ideal as you would like, but you have to do things a certain way. And if you can pin it down to a very small number of people and hold them accountable if something goes wrong, you can sort of keep things under control. So that's what we did. And I thought nothing of this. I thought that it was just the obvious thing to do, and everybody around me agreed. There was no dissent when we made this decision. Everyone thought that we should be strict about privacy right from the word go. And so that was in place before we actually went live on the internet. Later in my career, joining another company, I was surprised that 5 years after the company had started, it was still the case that everybody in the company could see the raw logs from a search engine. And I was just astounded. Thousands of people were allowed to see these things, which I just couldn't believe based on what I knew from what I'd seen initially at DEC.
That's incredible. So just that's an amazing story. The whole inside perspective on Alta Vista for what it was and the blow-by-blow accounts. Just tell me a little bit. So you obviously you moved on from DEC. I think you were there up until the end when it got acquired. Is that correct? But then you've moved on to other companies since then. Who have you moved sort of through, and where are you now?
So I stayed at DEC when it was acquired by Compaq, and I left just before it was acquired before Compaq was acquired by HP. So that was in 2001. And the main reason that I left was that it was clear that in the acquisition by HP, the culture at the research labs would be completely different. And so many of the people who were researchers at the labs left at that time.
How is the culture going to be different? Because we often think of them, they're often seen as being kind of similar, but you think it was different. How was it different?
So HP labs had a very different style about doing research. Now, I do not want to suggest that it was necessarily worse than the style that was used at DEC's research labs, but it was very different. The main difference was that at HP, the impression I had was that if you wanted to start a research project, you needed to get buy-in from some product group. And the product group might provide you with sponsorship. They might give you budget. They might give you headcount. They might help you in various ways. And so that caused many of the projects at HP Labs to be tied directly to product efforts. And of course, the benefit of that is that it makes the research perhaps much more relevant to the company. At DEC, at least at DEC Circ, where I was, the strategy was that you put all of your effort into your hiring decisions. And so what you do is you hire people who are good and who want to work on the things that you think would be beneficial to the company or to the lab. And so they come along, and then you say, you can work on whatever you want. And they do. But the things that they want to work on happen to be the things that you saw that they were interested in when you hired them. And so they work on the things that are in the area that tend to be good. There's less direct connection between what the researchers then do and the product teams. You might say that the research has more of a chance of being more forward-looking because the researchers have more of an opportunity to do whatever they want. They don't have to scramble for funding for a particular project. So there's good and bad points about each system. One of the things that's important about the situation, though, is that the people who came to DEC's research labs chose to be there, and they liked that system. If they wanted to work in the other type of system, they could have gone to HP Labs, but they didn't. One of the things that I can say is that, of course, we were competing with the other labs when we were hiring people, and we were competing with universities. And we sometimes lost a candidate who went to a university, say, or perhaps to Xerox PARC. We never lost a single candidate to HP Labs because the people who applied to us wanted our style of research and not the HP Lab style. So that's not to say the HP Lab style isn't beneficial, and it may have been better for HP, I don't know. But the people who were at the DEC Research Labs didn't want that, and so it's unsurprising that they fled when they were told they had to work that way.
And where did
so
you
what
go?
happened?
And where did you go to? And what was your journey?
Yeah. So what happened was that some of my colleagues negotiated with Microsoft for Microsoft to open a lab only a few miles away from Palo Alto in Mountain View, and they started a new lab. And in the first few weeks, I moved over to that lab, and so I was working with some of the same colleagues that I had been working with. However, Microsoft was different, as you can imagine. I discovered that I did not enjoy myself as much. One of the problems was that I seem to be allergic to Microsoft Windows. Microsoft Windows is a fine system for customers, but if you're a developer, it is less fun than other systems. I ended up writing my programs in a style where I would have two machines on my desk, and one was a Microsoft Windows system and the other was a Linux system, and I developed the software on the Linux system and then I ported it to Microsoft Windows because I just hated developing the software on the Windows system. Another problem was that in my second year at Microsoft, they decided that they wanted to build a web search engine because they felt they needed to compete with Google. And they noticed that I had worked on a web search engine before, and so they wanted me to work on that project. The project, however, was being run out of Redmond in Washington State. But I was in California. And so I found that I had to travel to Redmond by plane, perhaps a couple of times a week for months and months. And that gets pretty old quite quickly. So I became quite unhappy at Microsoft. I was not enjoying the work and I was not enjoying the traveling. I wasn't getting to write as much code as I wanted because on that particular project, they wanted me to design the overall things and have a bunch of other people write the code. And that's not really what I enjoy. So after a couple of years at Microsoft, I looked around for somewhere else, and I noticed that at Microsoft, it was quite common for me to come in at the weekend and there'd be no one else in the building. There would just be me. But I also noticed, because it was on my way as I walked to the Microsoft campus, I would walk past the Google buildings, and I noticed that their buildings were always full of people. Their car parks were always full, even at the weekends, and they seemed to be enjoying what they were doing. And I knew people there because some of the people from the DEC labs had moved to Google. And so I expressed interest in going there, and they said yes. I insisted on interviewing, even though they knew me quite well, because, as I said, a bunch of them came from the DEC labs. But I wanted to interview because that would cause me to meet people that I didn't know. So I did that. There were a couple of amusing things happened when I joined Google. One was I was all ready to sign on the dotted line and join Google. And then I realized, one of the things you have to think about in the United States is medical insurance, which you tend not to have to think about in the UK as much. So I read the medical insurance information, because medical insurance in the US is normally provided by your employer. And I noticed that there was a lifetime limit on how much they would pay out. And I did a calculation in my head, and I realized that it wouldn't take that many years before I would be bankrupt because they would stop paying for the medication that I needed for the CIDP. And so I told them, I can't afford to work for you. I would go bankrupt. And they said, oh, let's consider that. So they went off and eventually changed the way their medical insurance worked at Google to fix that. And at that point, I joined. The other thing that was amusing was in my first few days at Google, you may remember that Google early on had a slogan, which was, "Don't be evil." And of course, at the time, Microsoft had a reputation for what one might describe as sharp practices, and they were considered to be evil by many people in the industry. Because they were so dominant, they could treat other companies quite poorly and get away with it because there was nothing that anyone could do because they had a near monopoly on desktop operating systems. So one of my colleagues at Google said to me, how does it feel to be in a company that isn't evil? And I didn't know what to say, but because I didn't want to upset him, but I was thinking to myself, you just wait. If Google becomes successful, there will be people who think that Google is evil, because once a company becomes very dominant, it tends to behave differently, or even is perceived as behaving differently. And I think that has become true. I think many people now look upon Google in the same way that people looked upon Microsoft around the year 2000. But anyway, I have been at Google ever since, so I've seen Google change a lot. I joined Google in 2003. So now I'm one of the people at Google who's been here the longest. You know, I'm in the 99.9 or maybe 99.8 percentile of tenure at Google. And of course, since I'm now much older than I was, my hair has gone grey. And as a result, I have lots of conversations where people look at me and think of me as the wise old man who doesn't know what's going on anymore, because so many things have changed. It is remarkable how often I encounter colleagues who don't know about the history of computing. They don't know who David Wheeler was. They don't know what he did. They don't know the people who were at DEC, and they basically don't know anything unless it was invented after the web came along, because the only thing they know how to do is look things up on the web. And so if it was in a paper that was before around the mid-90s, they won't know about it.
So tell me,
I have an anecdote.
Go on. I was going.
Well, I have an anecdote about that. That at one point, a team asked me for some advice on how to build a particular piece of hardware, and they said, "Oh, we don't know how to do this thing. It would take too much RAM, and so we're thinking of giving up." And so I told them the solution, and it took a while to explain it to them, but then eventually I got it into their heads, and they said, "Oh yeah, we could build that." And so they went off and did it, and they came back a year later and said, "Oh, it worked. It was great. We should patent this." And I said, No, you don't understand. I was able to tell you about this because the patent expired some years ago. This dates back to a patent from 1987 at DEC. and of course they knew nothing about it because they didn't know how to look up such a thing because it wasn't on the web directly unless you went through the patent database.
Well,
Anyway.
that kind of brings you around to a nice circle, because I was about to ask you the fact that DEC indirectly is still influencing things today. You know, that pattern is a very good example. What do you think is, what do we have left from DEC? What is its legacy, I suppose, on the world today? And what have you taken from DEC to, I suppose, where you are today? Which it can be anything, you know, anything at all about the culture, what you did, the knowledge acquired, or do the right thing, anything that you feel has carried with you, or how did DEC shape you to be where you are today, I suppose?
Well, I suppose many things. There's a lot of things that I learnt while I was at DEC, things that either I did or more often that my colleagues invented that I am able to apply all these years later just because I know it. An excellent example is when I first came to Google, I did not know what to work on, what project to work on. And so, and no one told me what to work on. So I attended other teams' meetings for several weeks, just listening to the meetings and trying to work out what problems these other teams at Google were having. And I realized that one of the problems they were having is that they did not have a solution to what's called the distributed consensus problem. This is where you have a distributed system and it needs to make a decision. So the classic example is that you have a system and you need to elect one of a number of servers to be the master server to act and coordinate everything else. And if that machine crashes, you need to elect another one. And it is very important not to have two machines believing that they are the master simultaneously, because then they would conflict and everything would go wrong. And they had no solution to that. And so there was at least one system at Google at the time. And every time the master crashed, the operations staff had to manually nominate a new master. And it was very slow and it didn't scale. And they needed to replicate this type of system many, many times. And it was causing severe problems for them. But I had worked with Leslie Lamport at DEC. And so I knew how to do distributed consensus because One of the things he invented is called the Paxos algorithm, which is a solution to that particular problem. You might almost say it's the only solution, because all solutions to that problem look incredibly like Paxos. You can only make minor variations and have it work. And I also, from my work on distributed file systems at Cambridge, knew how to build distributed caching systems. And so in my head, I put these two things together and came up with a design for a distributed lock server, which is still in use at Google today. I didn't have to invent anything new. I just used things that I knew from earlier in my career, things from Cambridge and things from DEC, put them together, built the thing, and it worked, and it still works. Let's see. I am constantly reminded about the differences between the hiring strategies at DEC and at Google. One of the things I find very interesting, it's another one of these things that's very different, and you can't say that one is necessarily superior to the other, but I know which one I prefer. At DEC, as I mentioned, we were very careful about hiring. Interviews, at least at DEC, they lasted 2 days, and we made sure that everybody liked the person before we made them an offer. If someone hated them, we said no to that person. And the result was that everyone got along, and it was a nice working environment. There were very few conflicts. One of the most important pieces of information we used was letters of reference. Because even if you interview people for 2 days, you still are seeing only a tiny fraction of their personality and what they can do and how they behave. And it's much better to talk to someone that you trust who's worked with them for months. That's why we had a summer intern program, because it basically is like a 3 or 4 month interview. However, it has, so it leads to good colleagues and people who know their stuff. It has a disadvantage, which is that it is quite unfair. If you, in your educational path, did not go to one of the universities that we were plugged into, where we knew people, so we could ask, how is this graduate student? Then we were much less likely to know your name. We couldn't ask anyone about you. We wouldn't know to invite you for an internship. And so you were much less likely to get hired, because if you just applied, we would say, well, we don't know anything about this person, and we have no way to find out. And so in some sense, that's very unfair, because it amounts to giving an edge to people who've gone through the right path through their education or prior parts of their career. At Google, they emphasize the fairness much more. So at Google, they put significantly less emphasis on letters of reference, say, and they put a much more emphasis on the interviews, and they conduct the interviews in a different way, where at DEC, my job as an interviewer was to ask questions which would allow me to decide whether I wanted to work with this person. At Google, my job as an interviewer is to ask questions which will provide evidence which I will give to an anonymous committee of people who, in a double-blind fashion, will assess whether this particular set of answers to the questions is someone that they think they should hire, which is a very different process. It's much fairer. I don't think that it leads to necessarily the same uniformity of quality in the hiring, but it is fairer. It's a hard choice to make.
Do you think there's any one thing you would say you've brought? I can see the research, the knowledge. Any one other thing you say you've brought from DEC with you, or any looking at the world today, you could look around and say, yes, the DEC legacy is alive, or is it not got a legacy? I suspect you're going to say it has got a legacy, but I'm interested to hear what it is.
I think so, but there are so many things that were invented by DEC, and it's influenced so many people. One of the things that's noticeable is, even though the alpha architecture done at DEC is no longer being actively developed, and there are probably some companies that still have old alpha machines and use them, but no one buys new ones, and no one manufactures new ones. HP stopped manufacturing them. It is still the case that if you talk to people and you discuss CPU architectures, and you happen to say, oh, my favorite's still the alpha because it's so clean, there's an 80% chance that the person you're talking to will say, yes, you're right, that's the cleanest machine I ever saw. It was exceptionally good in that respect. I mentioned the Paxos algorithm, that lives on. There are, of course, many hobbyists who keep alive DEC machines. I do myself. I have a PDP-11s and VAXs and alphas at home. There are yes, I don't know in what other ways DEC is being kept alive, but there are certainly many papers that would not have been written with many important discoveries that were done at DEC, which perhaps wouldn't have existed otherwise.
What do you think ultimately were your feelings on when the acquisition happened? Obviously, you left after Compaq, and then obviously you saw what happened from outside. Any kind of feelings when you saw the final acquisition and DEC went out of business or was acquired by HP? How did that make you feel? Because you've come a long way with that, haven't you? It's given you an incredible life and journey, hasn't it? What did you feel when you saw that finally happen?
Well, of course, I was sad. For me, the acquisition by HP was very sad because, of course, to a certain extent, DEC and HP had been competitors, and it felt like HP had finally won. And perhaps they deserved to win, it's hard to know, but it was sad from that point of view. It was sad that HP did not want to continue to do research in the same way that DEC had fostered research. Later, a few years later, of course, HP went even further, and most of the people at HP Labs that I knew left HP Labs because they reduced the number of people working there tremendously. So that was sad also. So in general, I was pretty sad about the acquisition of DEC by HP. But from the company financial point of view, it might have been the only thing possible at the time. I don't know.
And how's it been, I suppose? Go on. So you were going to say?
Oh, I was going to say, of course, when DEC Compaq was struggling financially in the lead up to HP acquiring Compaq, Compaq sort of was struggling, clutching at straws, trying to sell off parts of the company in order to survive. And so much of the semiconductor stuff went to Intel. I can't remember who bought it, but they sold off their networking division, which I had been involved with because of the networking projects that I'd worked on. And that too was sad. So it wasn't just HP's acquisition that was sad. It was sad that you could see in the last year or so of Compaq's history before that HP acquisition that it was falling apart. It was, in some sense, being given away because it just couldn't keep up financially. It was being nibbled away at by PCs and then the dot-com bubble, and it just couldn't keep up. It couldn't evolve quickly enough.
It sounds like you had a great life-changing experience as a result of all that DEC, didn't you?
Oh yes, I enjoyed being at DEC tremendously, and if that lab still existed, I would still be there. It is absolutely certain that I have made much more money at Google than I ever would have made at DEC, because I managed again, by luck, I managed to join Google before their IPO. And so that helped tremendously. But I've always felt that even though I have made most of my money at Google, I did most of my useful work at DEC. That was where I did the best things, I had the most fun, and I had the most impact, I felt. And later on, I would characterize my work in other companies as being that I reused the things that I learned at DEC rather than doing absolutely new things for the most part. A few new things, but not as much.